here, it's modulo 8, and we have the product of the squares of a bunch of odd numbers. 13 squared times 15 squared times 17 squared, and the pattern continues ending at 29 squared. And so this is a product, not a sum. Now, the approach here, it could be quite tedious, or you could look for some sort of general pattern. Let's just take a look at 15 squared for now. Let's just see what we can do with that, because it's a typical odd number, let's say. So 15 squared. Now, what I would prefer to do right now is build this up. So let's look at what 15 is congruent to mod 8. 15 is congruent to 7 mod 8, right? And y'all, this is modulo 8 right here. I won't write that down. That's because 15 minus 7 is 8. In other words, more generally, 15 minus 7 is divisible by 8, okay? Now, from there, you can treat a congruence very much like an inequality, just an equality, a straight inequality. So this would imply that from here, we could square both sides, and you get 15 squared, okay, is congruent to 7 squared, but that's 49, right? But notice we catch a break right here. And y'all, this is the property that I'm talking about, that if you just thought of this as an equality, even though in equality 15 would never be equal to 7, congruence has a lot of the properties of equality, like reflexivity, what do they call it, transitivity, all that kind of stuff, you know? And so, but this right here is actually congruent to 1, mod 8. And I'll go ahead and write mod 8 there just for the sake of being complete here. All right. And so what we've seen right here is for this particular odd square, we get 15 squared is congruent to 1. So you could actually put a 1 right here as far as solving this congruence, right? So let's see if we can learn from that and take a look at the more general case. If you have an odd number, and we'll just write it like this, 2k plus 1. Okay, notice that 2k plus 1 quantity squared would be the kind of the form of any of these factors up here. So 2k plus 1 quantity squared is equal to 4k squared plus 2 times 2k, which is 4k, plus 1, right? Now let me write this parenthetically, okay, because maybe that'll enhance the readability here. So 4k plus squared 1, I mean 4k squared plus 4k plus 1, you can write that as equal to, you know what I'm going to do, I'm going to factor a 4k out of these first two terms. And so what we get right here is 4k, parentheses maybe not necessary here, 4k times k plus 1. Plus 1, okay? But notice, folks, that this has to be a multiple of 8 here, because you have a 4 here, and then you have consecutive integers. So one of these numbers, k or k plus 1, is even, right? Okay, so this part right here has to be a multiple of 8. We'll call it 8. Okay, we'll call it 8m, let's say, plus 1. Okay, but this is certainly congruent. If 8k plus 1 is certainly congruent to 1 mod 8, right? Everybody comfortable there? So you know, what we've done here is we've started with an arbitrary odd number and squared it, and concluded it always has to be in this form 8m plus 1, which is necessarily congruent to 1 mod 8. You subtract the ones and you get a multiple of 8, right? Okay, so what does that mean? That means in general, each one of these is in a form, like for example, 13 is 2 times 6 plus 1, 17 is 2 times 8 plus 1. So all of these are in the form, And so if you want to call this, let's say capital A up here. Okay, we'll call this whole thing capital A so I don't have to rewrite it, folks. But we can see that A, okay, would be congruent to 1 times 1 times 1. You see in this exciting 1 times 1 for these three positions here, and then let's put the dots. And then the final two positions there, 1 times 1. Okay, but that's certainly equal to 1 mod 8. Hey, folks, and that's our proof. The answer to the question would be A equals to 1 based on this analysis. So again, you could have done each one of these individually. And it would have gotten tedious, but you could have done each one of them. I think there's 9, 1, 2, 3. Yeah, I think there's 9 of these. So you could have done each one individually and deduced that each one was congruent to 1. But this general truth right here allows you just to substitute ones in for the congruence and conclude that A has to equal to 1. So I hope you like that.